computer. Okay, good. Good. So we move this one away. Come here. Mhm. So this afternoon, we are going to be looking at a new module. Not really a new module, a new topic inside the module we started in the morning. And in the morning, we were talking about, we did introduction to networking. So right now, we are going to do network concepts. I believe that is what we are going to be covering. Yes, networking concepts. So that is what we will be covering right now. So let us go. So this is a relatively long lesson, but compared to the one that we had in the morning, but still, I'm going to try and make it as understandable as possible. So we will be looking at the slides and then we'll be explaining a few concepts apakule. And remember to watch the video I shared in the morning about OSI. That was very important. So when you are talking about networking concepts, it's important that after introducing a topic, we now look at the terms that you're going to meet in the process of learning networking, the terms that you're going to meet, or what in Swahili I hear them call muundo msingi, and the fundamentals or the building blocks of the whole of this topic called what? Called networking. So we are going to start on this and part of our objectives, we have 3 key objectives that we hope to meet by the end of this lesson. So objective 1 is to distinguish between different types of networks. Objective 2 is to describe common network topologies and network management models. And then objective 3 is to list different types of network protocols. And you will find that this is actually a continuation of what we covered in the morning. So some of the terms that we talked about in the morning, you'll see them reappear here, and then you'll now be able to even get a better understanding of them. So we had already defined computer networks, and we said that a computer network is actually, it comprises of computers that are interconnected together with other devices, creating a network. And now these are the networks that now we want to do a little dive into, just to understand when you're talking about computer networks, what are the different types of computer networks that are available for us? What are those computer networks that we are going to be dealing with? And I know this class, there are people here who might have the know-how or rather the knowledge of computer networks. So tell me, in your own understanding, do you know of any type of a computer network that you can tell us hapo kwa chat ama tuambie by unmuting? Anybody? Types of computer networks? Sorry, repeat. Is someone talking? Yes, LAN and WAN. LAN. Good. Any other network that you guys know of? Apart from LAN, apart from WAN? Yeah, there is MAN. Awesome. So LAN in full is local area network. WAN in full is wide area network. And then MAN is metropolitan area network, if memory serves. So let's see. Now, we are going to start with LAN. And from the standpoint of geographical span, 2 of the most common types of computer networks are normally LANs and WANs. And we say that LAN is local area networks and WAN is wide area network. Now, a LAN connects devices in a limited geographical area. You see that? A LAN connects devices in a limited geographical area, such as a floor, a building, or a campus. So, example of flow, it might be maybe in an office where you are at. You're in an office and then you have a couple of computers that are connected to each other, and they are connected to a switch, and they are connected to a router. And then apart from just those computers, you also have a printer that is shared by all those computers. So different people that are working on different computers are able to send their documents that need printing to the printer. You see, and the same, you would also find that kind of a setup in a cyber. Most of the cybers that we go to, we normally use LAN. They normally use LAN, and you can also create your own LAN, or you can rather configure your own network, your home network, to take up this type of a network, where you are now connecting again the devices you have. Say you have more than 2 computers, you want to connect them to a switch, and then maybe you have how do you call it? You have a printer, you want to put it in your network. You have your TV, you want to put it in your network. So that sometimes when you want to watch a movie, say from your machine, and you want it to be sent straight to the TV, you can do that. I've done that a couple of times. Or there are also those times that we can actually also connect our smart TVs to things like the router wirelessly or wired, depending with your preference. You see, now all that is an example of what we call a local area network. Now, when you're talking about a building, you can have a building. Let's say it is an organization that has this building, and then it has different floors. And now you want to make sure that people maybe in the finance department who are in a different who are in a different how do you call it, who are in a different department, maybe they occupy a different floor, can communicate with those ones who are in another floor but within the same building. So that is also a local area network. So something like a campus also, you get that we have different departments within campuses. Maybe we have a department for computer sciences, a department for engineering, we have a department for biological sciences, department of medicine, department of law, etc. And now they want to communicate together. So that can also fit this kind of a network. Now, looking at this diagram here, you can see that we have hosts. These are computers, and then connected to a switch. Similarly, we also have hosts here connected to a switch. Then these two switches are connected to the router. So this one makes it possible for traffic to flow, to flow across this network. It makes it possible for traffic to flow across that network. Now, LAN is the example. LAN in the example. So when you're talking about LAN in the example above, a LAN with one router, 2 switches, and 3 nodes under each switch. That is what we can see. Hapo ukiangalia hapa, we are being told what comprises this network. So we have a LAN. This is a LAN network which has one router, as you can see, 2 switches, and then we have 3 nodes under each switch. So this switch has 3 nodes. This other one also has 3 nodes. So each switch or subnet, so the switches in this in this setup represents a subnet. So each switch or subnet can represent an office floor or building within the same corporate office or school. LANs commonly use the Ethernet standard for connecting devices, and they usually have a higher data transfer rate. You see, they have a higher data transfer rate. So wireless technology is also commonly used for LANs. Just the same thing I told you when I was talking about the home network. Same way that you can connect your TV or your desktop machine using an Ethernet cable, you can also do it wirelessly, because modern day routers support that. Then after LAN, we have WAN. Now, think of it this way. Mona, the first one you tumesema, those are 2 switches. Those 2 switches are connected to a router. That one creates a LAN. But now, when you have multiple LANs and you want to connect them together, you can now connect these multiple LANs into what we call a wide area network. Now, a WAN connects devices in a large geographical area, such as multiple cities or countries. WANs are used to connect LANs. WANs are used to connect LANs. So we can also say that LANs are actually a subset of WANs. So you have multiple LANs coming together to form what? A wide area network. So look at this example. We had our switch, and then we had our host. You can even have another switch here and host, and then these 2 might be connected to the router. But in this case, let us just use one. So this switch, and then we have these nodes, then this other switch, and then we have these nodes. Now it is router to router connection. You know, router, this router, the whole of this one here is a LAN and this one is a LAN. But again, now they are connected together. The two routers, router A and router B, are connected to a main router that now makes it a wide area network. Now, once in the example above, a one with 3 routers, 2 switches, and 3 nodes under each switch is what has been presented. Then examples of ones are 2 corporate offices located across United States connected by a WAN or the internet. So the internet is an example. Yes, Musembi. Nodes, you can think of nodes as points of connection to a network. We had defined that one Asubui, and we also talked about it back when we were doing the introduction. So, sorry. So, when you're talking about nodes, think of them as points of connection of a network. You remember I gave this example of you have this cat tree and then you have these 2 branches. So these branches are connected to this main tree. So those are what we call nodes, you see. And then within these branches, you can have sub-branches. So those ones are also called nodes. Yeah, I hope that one makes sense. So we are saying the best example of a wide area network is actually the internet, because what the internet is, it's actually a connection of many local area networks that have come together. You see, you've taken my local area network, you've combined with Dan's local area network, you've taken Ivy's local network, you brought in Abby's local area network, and then it becomes what? It becomes that wide area network. So companies, you can get a company like, let's say, for example, a company like Lanley. Lanley might be having a branch, say, in Nigeria, and now they want to make sure that they are able to communicate. Lanley Kenya wants to communicate to Lanley Nigeria. So that one becomes very possible when they are connected, and now there's a way you can actually configure such that the connection is faster. You know, the connection is faster and the connection is secure. You know, and what do you do? How do you do that? You achieve that by using what we call wide area network. So such that, let's say, for example, an instructor here in Kenya, in Lanley, Kenya, might want to talk to an instructor that is in Nigeria. Maybe we'd like to align in something with content or stuff like that. So that one makes it very possible. And you see, when now you are connecting across borders, we are now using the internet, which is the biggest example of wide area network. So the internet is considered to be the largest one, and one uses technologies such as fiber optic cables and satellites to transmit data that are used to connect LANs. You see, so we talked about fiber optic cables, and I believe you guys know what satellites are. So using these two, it's now possible for us to transmit data. You know, to transmit data, let's say talking from here to someone in the US, someone in Nigeria, to someone in Ghana, wherever, in Europe, anywhere. It's very, very possible over the internet. So this pictorial representation here shows us the difference between a LAN and a WAN. And you see a LAN has 1 router, 2 switches, and then 3 nodes under every switch. So for department A, we have 3 nodes, and for department B, we have other 3 nodes. Now, if you take this LAN, let's say this is for, again, using the same example, this is for Lanley Africa Kenyan branch, and then you have the same LAN for another Lanley Africa Nigerian branch, and now we want to communicate. You know, the 2 want to communicate. So we will communicate over the internet. That's why you are seeing 2 WANs, you know, 2 LANs, 2 LAN connections under one. We have LAN connection A with the router and its 2 switches and its 6 nodes. And then we also have router number 2 with 2 switches and 6 nodes, 3 under each switch. So that's what we can see there. So this is how you get to see. So when you say that one comprises of multiple LANs, this is what you see. And it needs not to be 2. It is multiple. Multiple is 2 or more. I hope that one makes sense. Multiple is 2 or more. So LAN is just a summary. LAN is found within the same building or floor, but one can be geographically different locations. However, they are connected by a corporate WAN. They are connected by a corporate wide area network. So network topologies. So we've talked about the 2 types of LANs, the two types of network areas. So we have WAN and LAN. There is also MAN. I'll leave MAN for you guys to go and think about it and even do some research over it. But now I want us to dive into network topologies. Again, similar to what you said about what makes up a LAN and what makes up a WAN. Now, when you're talking about network topologies, here we are talking about patterns that shows how nodes, remember Musembi has asked us what are nodes, those points of connection, how these nodes connect to each other. So when we are talking about nodes, nodes can be computers, and computers are not in isolation. These computers are connecting to the network. So when we are talking about these computers, how are we arranging them to achieve that connectivity? How are we arranging them? So that is what we mean by network topologies. So from our notes, we say a topology is a pattern or a diagram that shows how nodes connect to each other. So it is a pattern or diagram that shows how nodes connect to each other. Computer networks use different topologies to share information. So there are two main topologies that you need to know of right away. So we have physical topology and logical topology. Again, back to the example I gave you guys in the morning talking about CCNA, I told you guys that if you chance to do that course, you will be using something we call a Packet Tracer. Packet Tracer is a small app that you download to your machine, and then you can use it to simulate labs. You see the same way you are doing labs in Vocarium. So Packet Tracer is for guys who are doing CCNA. So you'll be able to simulate, and you'll be able to drag and drop icons that represent, say, computers, icons that represent servers, icons that represent racks, icons that represent routers, switches, different connecting cables, you see. And then even within that, there are actually two types of topologies that you can access there. You can access physical topology and logical topology. So when you're talking about physical topology, we are referring to physical layout of wires in the network. So when you pick a cable and say you want to connect, let's say you want to connect which cable? Yeah, you want to connect an Ethernet cable from your router. I'm talking about the Packet Tracer. Sorry, from your router, and you want to connect it to your machine. So you'll be told, connect it here and then connect it there. Then once you connect, you'll see the lights start to blink, telling you that the connection has been successful. You see, that's one of those. And some of them will not even blink. They'll require you again now to access them first. After you've accessed them, maybe through the console, then you configure them. So I believe that is what Ridge was talking about when he was talking about VLAN configuration. So VLAN is just virtual LAN configuration. V is for virtual. So another type of topology, apart from the physical one where you're connecting wires, there is this that we call logical topology, which refers to how data moves through the network. So once you've connected everything, and then now you click on the action button, you will see it is normally represented as a letter. You will see something move, let's say, from computer A through the switch to the router to enter a different LAN, and then get to the destination where it is supposed to go. And I told you guys that when packets of data are traveling and they're trying to find their way to the destination, they use the MAC address as a guide. So it is important, very important, to understand network management models, because they define the roles and relationship of devices in your network. You understand? So it is important to understand network management models because they define the roles and relationship of devices in your network. Now, examples of network topologies that we're going to look at include bus topology, star topology, mesh topology, and hybrid topology. Bus, star, mesh, and hybrid topologies. Yeah, I know there are others, of course, there are others, but these are the ones that we're going to focus on. These are the ones that we are going to focus on. And remember, here, a reason why you are doing this course is just to let you know that the same way we have networks that we are used to in an on-prem environment, there are similar networks in the cloud. So we start by explaining what is familiar to you or what you can easily see for you to understand and appreciate that which you cannot readily see. So now when you go to the cloud, and even in the cloud, under roles in cloud, there is a role for cloud network engineers. No, it's not that you're going there to connect mawingu moja na mawingu ingine. No, you're not connecting clouds, but you're connecting devices that are found in the cloud. You know, if devices are found in the cloud. And now when you start talking about VPCs, these things will start making sense. It will start clicking, clicking, clicking. And if this is your liking, if this is direction that you'd like to take, then by all means, just let us know, and kama kawaida, we will guide you appropriately. So looking again at the physical topologies. Physical topology, we say this is how devices are connected within a network. And when you are looking at those devices, because there are things that you can see, there are things that you can see. Say you've been given like 4 or 5 or 6 computers, and they're in a network. If you enter an organization and then you look at how the computers have been connected, you can easily say these ones have used a bus topology or star topology or mesh topology. So bus topology positions all the devices along a single cable. So you have a single cable, and this cable is actually a transit. It is like the barabara where data packets are moving, and you'll find that this is either connected to to a router, of which now this router is what gives these clients or these nodes access to the internet. You see, straight line, and then you can clearly see we have computer A, client A, B, C, and D arranged in that order. You see, so that is what we call bus topology. Then for star topology, you see, it is taking, okay, first of all, back to bus. Why is it called bus? Ukiangalia, it looks like, if you just picture a bus, how people sit in a bus, In a bus, you normally have an aisle in between, and then you have seats on the right, seats on the left. Then the bus is moving. Now that is a bus topology. Picture it that way. Then for a star topology, look at how the computers have been arranged. You see, you have a switch in between, and then you have the computers surrounding it in a star formation. So now we have those 6 computers arranged in that order. So that's what we call a star topology. So every node in the network is directly connected to one central switch. So for a star topology, every computer, made simply, every computer you see there is directly connected to a switch. And I told you the switch in itself has 2 things. The switch has ports where you can how do you call it? Where you can now use Ethernet cables to connect to your client machines. And then it has that ability now to connect to a router, which will then give the clients connected to it access to the internet. You understand? Access to the internet. Good. Then we have a hybrid topology. So when you're talking about hybrid, anytime we talk about hybrid, including cloud hybrid. So when you talk about hybrid in terms of cloud, and cloud designs, or the design of or the design of a cloud adoption strategy for a company, if they decide that they want to go the hybrid way, it means that they want to combine 2 clouds, 2 separate clouds. They want to combine public cloud and private cloud. So here, when I talk about networking, and I've already told you that there is bus topology and star topology as the main types of topologies for networks. Then now when you bring them together, when you bring a combination of them together, you get what we call a hybrid topology. So this one combines 2 or more topology structures. And for the example that you see hapo chini, that is a star bus topology. It is a star bus topology. Why is it star bus? Look at the switch, look at the clients. The clients are directly connected to the switch. That's what makes a star topology. Apart from it taking the star shape, the fact that they are directly connected to the switch, that one already makes it what? It already makes it a star topology. And then these switches are all lined. No, they are all lined across one cable. No. So you have switch 1, switch 2, switch 3, all of them lined. So the switches are taking the bus topology, and then the clients are organized in what we call a star topology. Hope that one makes sense. Yeah, that one you read for yourselves. I'll jump straight to mesh because we haven't talked about mesh. So a mesh topology is a complex structure of connections that are similar to peer-to-peer, where the nodes are interconnected. So mesh networks can be full mesh or partial mesh. They are full mesh or partial mesh. Let me see. Someone has shared something here. simplified. A star topology, logical star, passes through a central device, switch. Devices do not communicate directly. All communication goes through the central node. Nice. Mesh topology, every device can connect directly to every other device. Yes, that's what we're talking about right now. Provides high redundancy and reliability. Can be full mesh, all connected or partial mesh, some connected. Examples are ones connecting multiple sites. Then we have hybrid topology, a combination of two or more logical topologies, provides flexibility and scalability. Examples are star ring or star bus topology. Yeah, there's also a ring topology. Thank you, thank you, thank you, thank you. Awesome. Thank you, Musebi, for that. That's awesome. So again, we are saying that it can either be partial mesh or full mesh topology. And for partial mesh, all devices are connected to at least one or to at least two other devices, at least two, not one, at least two other devices. But for full mesh topology, all nodes are interconnected. As in computers, if computers are what forms your nodes, then all of them are interconnected. Computer A is connected, computer B is connected, computer C, vice versa, evo. Then a full mesh provides full redundancy for the network. It is an expensive topology because it requires each node to have multiple network adapters and cables. You will most likely find a full mesh topology in a wide area network. So wide area network, you are most likely going to get a full mesh topology because you don't want any of those computers that are connected in that network to miss out on the transmission of data. So when data is transmitted, it has to reach all the nodes. So that's why you have a full mesh topology for a wide area network. Hybrid topology, we've talked about it, and we've said a hybrid topology combines two or more different topology structures. It is usually found in large organizations where separate departments have personalized network topologies to accommodate their network usage and other requirements. So today, the bus topology is the star bus topology is the most common hybrid topology. And you've seen an example, Parejo, in terms of the diagram, how it looks like. Then away from the physical topologies, you can also look at logical topologies. And here we are talking about, we are saying that logical topology refers how data moves through a network. And the easiest way to look at it is to think about the Amazon Virtual Private Cloud, or Amazon VPC, which is an example of a logical topology. So a VPC, by definition, is a virtual network that allows you to launch AWS resources that you define. You know, a VPC, by definition, is a virtual network that allows you to launch AWS resources that you define. Think of it this way. When you create an AWS account, leave alone the ones that we have in the labs, but when you create your own AWS account, you have two options. Every AWS account comes with a default VPC already created for you. So if you don't want to go into the hassle of creating a VPC, that's okay. But for the jobs that you guys will be taking as cloud engineers and other cloud roles, you might be required to create a specific VPC that fits the needs of your organization. You don't want to use the virtual VPC because, again, if you use what has already been created for you, then chances of you modifying what has already been created for you is a bit, it's a bit restricted, and it does not give you the flexibility that you would enjoy if you are to create your own. So creating your own VPC is a good thing, and it is actually a very easy thing to do. So you need not to really worry about it. So by the end of the entirety of this module, you will have already known how to create your own VPC, and you will have known even how to define things to do with CIDR ranges in terms of IPs, you know, how to define the IP ranges that you're going to have for the different parts of your VPC. So a VPC, it's like the space that you have rented in the cloud. You see, the cloud is this big, expansive place, but now you've gone there and then you have bought your account, and then now you want now, by the way, buying an account, or rather registering for an AWS account. That is now you renting space in the cloud, having the AWS account first. That is you renting space in the cloud. That is your account. Then in your account, you can have a number of VPCs. I think the last time I checked, what was the maximum number of VPC an account can hold? Let me see number of, I told you things change with the AWS. Let's see. So, well, so you are allowed to have an account default limit is 5 VPC per region. 5 VPC per region, but this can be increased by requesting a quota increase. There's something we call quota increase. So quota simply means quota is QUOTA. Quota means what you have been allowed, as in the way they've said is 5 per region. But now if you need 10, you just need to talk to AWS support, and then they will see how they can increase that for you. You know, how they can increase that for you. So we are saying that by default, it is 5 VPC per region, and that one is actually an examinable question. That's an examinable question. So take note of that. An AWS account default limit is 5 VPC per region. 5 VPC per region. You know, and then other related quotas that maybe you can also take note of is that you can have up to 200 subnets per VPC. Up to 200 subnets per VPC. So think of VPC as your net. No, that's your network. That is that is the slice of what you have. And then, sorry, and then now this VPC, this one VPC, you can now divide it into, you can now divide this VPC, one of them. You have 5, but now you can divide one of them into a maximum of 200 subnets. 200 subnets is such a big and good number. But don't think that don't let this number fool you. There are big organizations that actually come close to those numbers in terms of the number of subnets that they are using. In terms of the number of subnets that you're using. And you'll discover that this one varies in terms of organizational complexity. How big is the organization? What are they doing? What is their demand? What are the regulations and compliance and governance issues surrounding how they can do certain things in the cloud? So all that is very important. So take note, 5 VPCs per region, 200 subnets per VPC. So we continue and say this VPC looks and works just like a normal network within a data center, with the benefits of using AWS services for scalability. For scalability. Then bus, star, mesh, and hybrid topologies all have logical portions as well. They also have their logical portions as well. Now, let me see. Did I see anything reasonable to talk about here? Okay, let us just go through this. What is logical topology? We've said it refers to how data moves through a network. That one we've already said, so that one makes sense. Examples of logical topologies, we said we have star, we have bus, we have mesh, we have hybrid, and we have VPC. VPC is also a logical topology. Then bus topology, we've talked about it. We say the logical topology and data flow on the network also follows the route of the cable. It moves in one direction. So in a bus topology, since that cable runs from, let's say, the router to the end node, so our data flow will also move the same direction. One direction. This is simple to configure. However, it only allows one computer to send a signal at a time. So you cannot have multiple computers sending their signals at any given time. So computer A needs to send the signal and finish before computer B can do it. So this is simple to configure, we said. However, it only allows one computer to send a signal at a time, which can cause network collisions that will bring down the network. It can easily cause network collisions. For example, if there is a misunderstanding, say computer A has sent and then computer B, maybe computer A is waiting for something, then computer B assumes that computer A has finished and then it sends, and then computer B starts receiving feedback when this one is still sending. That can be a collision. The collisions can easily bring down a network. That's very important. Star topology. This logical topology works with the central switch managing data transmission. So you have a switch that is managing data transmission. So data that is sent from any node of the network must pass through the central switch to reach its destination. Hakuna kubypass. The central switch can also function as a repeater to prevent data loss. It can also act as a repeater to prevent data loss. As in data passes through it, it makes sure that this data is cached in some manner or some form, such that in case the first attempt sending it fails, whatever has been held as backup can also be sent in the same direction to go and make sure that things get where they get. You see, repeater, mesh topology. Mesh topology is a complex structure of connections that are similar to peer-to-peer, where the nodes are interconnected. So we say that for mesh topology, we can have them either as partial mesh or full mesh, where we said partial mesh, all devices are connected to at least 2 other devices, but for full mesh, all nodes are interconnected. And we say that a good example of full mesh is actually wide area network. So that when we said it, then hybrid topology, we've talked about it, and we've said that this is now when you bring this individual 2 or more individual topologies together. Say you bring star and ring, or you bring star and bus, or you bring star, ring, and bus. So you are creating what we call a hybrid topology. And then we also looked at the VPC, which said it's a virtual network that allows you to launch AWS resources that you define. It is a logical network. It is a logical network. Now, when you are looking at the VPC, I told you that every account you create on AWS, it comes with a default VPC. All accounts come with the default VPC. Then you are free to create any number of VPCs you want. But remember, we've been told that you can only have a maximum of 5 VPCs per region. 5 VPCs per region. So an Amazon VPC redefined is a virtual network that allows you to launch AWS resources that you define. This VPC looks and works just like a normal network within a data center, with the benefits of using AWS services for scalability. So in the following table, you will see the similarities between AWS services and traditional network topologies and at the most basic function. So when you're talking about VPC, Amazon VPC, this is an isolated network. You can also have an isolated network on-prem. But now this is your isolated network in the cloud called the VPC. Then the subnet are network segments. You see, now you hear subnet. You have a network, a big network called Amazon VPC. Then within it, we have subnets. And we've said you can have a maximum of 200 subnets per VPC. Then firewall, what you see as a firewall in the traditional topology, in the AWS service category, you can have the likes of security groups, and we'll get to see what security groups do. And you can see we also have network access control list, or NACL, network access control list, or NACL. And then for server, what you get in your traditional topology as server is what in the AWS space you get it as Elastic Compute Cloud, or the EC2 instance. And you guys have so far been creating these EC2 instances, so that has been our server. I hope that one makes sense. Then now for these ones, you'll just read through these notes. There's nothing worth rehashing here. It's just a matter of you guys now reading through it, and you'll be able to understand. For instance, you're told here a network segment acts as a subnet and separates a network between offices or buildings. AWS uses subnets in every architecture. Every node, say EC2, belongs in a subnet. So you have this many EC2s, maybe you have 3 instances. You want to put them in different subnets. You can define your subnets either as private or public, the way we talked about it. And then firewall blocks traffic based on a set of rules. Remember, every time, and by the way, this is also examinable, but you will see it more when you continue with the networking. But you have to remember that every time you want to give access to traffic into your workloads or into your VPC, you can define what we call allow and disallow rules. So allow rules allows specific type of traffic to access your VPC through a specific port. So it's a specific type of traffic to access your VPC or your workloads through a given port. That is very important. That's a very, very important. You'll see us do those rules. So those rules are defined both at the security group level and at the network access control list level. So that is very, very important. So those ones now act as firewalls, and then they can also block traffic based on a set of rules that you define. Within a data center, there are servers, and now within AWS, you can use EC2 instances to launch an array of servers. An array of servers can be launched using what? EC2 instances. Now comparing LAN 1 and Amazon VPC. Comparing LAN 1 and Amazon VPC. So this is our LAN. You see, this is our LAN. So we have our LAN that has switch and 3 computers directly connected to the switch. And then now when you have 2 routers that are connected to each other, if you have 2 routers that are connected to each other, you have 1. But right now, let us just focus on LAN, how you will see LAN in the physical or in the on-prem environment, and its representation in the cloud. So in the cloud, for us to see a LAN, it is the connection between 2 availability zones. Remember, we talked about our availability zones. So we have the AWS cloud, that is your account. Then within it, we have a VPC, which defines a region. Let's say, for example, we decided to do US East 1 as your region. Then within the region, we have 2 availability zones. We have availability zone 1, which can be US East 1A, and availability zone 2, which can be US East 1B. And then inside each of these availability zones, you have subnets. You have one public subnet in availability zone A and one private subnet in availability zone B. You see, you understand? So these two, you can see these 2 availability zones, they act as, loosely put, your availability zone acts like, let's say, for example, availability zone 1 is the same representation to what we have as department A in this diagram. Then availability zone 2 is the same representation for what we have for department B in our diagram. You understand? And then that internet gateway you see up there, that internet gateway is what we call our router. That's our router, because that is what gives your VPC access to the internet. You understand? It gives the VPC access to the internet. So that's why it is iko hapo katikati. It's in between the two. So it can allow traffic from the internet. Once traffic hits it, sometimes you might have additional resources provisioned, something like an application load balancer, you know, something like that, which can also further help to route traffic accordingly. But now, using this just as is, you can see now these two networks that you see here, this LAN network, not really two. This LAN network, availability zone 1 representing department A, availability zone 2 representing department B, the 2 of them connecting to the internet gateway, it actually gives you a picture of what? Of a LAN. And then down there, what you see there is what we call a route table. So the route table normally defines the destination and the target. You know, the destination and the target. So our destination there is that IP address, and then the target is local. And then for the second one, when you see 0.0.0.0/0, that is normally routing traffic to the internet. That is the IP for the internet. So that one routes traffic to the internet. And IGW ID is Internet Gateway ID. And we'll talk about Internet Gateway so that you get to know the superpowers behind this awesome service offered by the AWS cloud. Good. So that is LAN. Sumona, I hope it makes sense. Our router is this instance. The switches are obstructed inside here. They're abstracted, rather, not obstructed, abstracted, so you cannot see them. But now these servers here that you see is like an instance here, an instance here. You can actually have like multiple instances, but you have this instance and this instance representing department A and department B workloads. And now our availability zone 1 is this, our availability zone 2 is that. Hope that one makes sense. Hope that one has made sense. Good. So you will read that one just for to deepen your understanding. Now let's move on to WAN and AWS VPC. So you remember we have looked at one LAN up there, and that LAN we have compared it to one VPC. So one VPC equals to one LAN. No, equals to one LAN. Okay, route table. And don't pay too much attention to route table right now. We'll get to a deep dive, but let me just say, for the route table, it actually shows you the destination and target for traffic. The destination and target for the traffic that is coming in or leaving your VPC. That is very, very important. Or the workloads, including the likes of Akina subnets, you know, it shows you that. So we will get deeper into it when we'll be defining what it does. So that is just an element of what your VPC must have. I remember there's a time I was trying to run some workloads, then I was getting an error. My workloads were not able to run. Then a colleague of mine akaniambia, able check your route table, if your route table is properly associated. Then I was able to do it. When I checked, I found that, well, I had not defined some certain parameters that I needed to. So correcting that, everything ran smoothly. So it's a very, very important thing, and Gideon will get to it. So I was saying, when you see this VPC here, this one represents one LAN in the physical, and this one represents another LAN in the physical. Now, when you bring two LANs together, when you bring LAN 1 and LAN 2 together, this one's now become what? This one now becomes a wide area network. You know, it becomes a wide area network. But in the cloud, we don't just call them wide area network. We call them VPC peering. VPC peering. Why? Because you know what to peer is. To peer is to connect. So you are connecting one VPC to another VPC, and it is possible to do that. When you define a peering connection, it makes it possible for VPC1, VPC in the US West 2 Oregon region to talk to a VPC in the US East 1 North Virginia region. You understand? It is very possible for those two to talk to each other. So that is a very, very important thing. That's a very important thing. And we can check this and say an example of one where a city on the West Coast can communicate to a city on the East Coast from same company within AWS is called VPC peering. This is beyond the scope of this course, of course. So you will be meeting a lot of VPC peering when you'll be doing your solutions architect and subsequent certifications, but not for this course. This course, that is a bit deep for you. And then this is an example of how this is achieved. So when a VPC is created, it is created in a region. We agreed with that, which is like a state. These are located across the US for high availability and redundancy. There are multiple regions in the world. However, for this example, we'll stick to 4 regions of the United States, where we have Oregon and North Virginia. In order for these two VPCs to communicate and share resources together, just like a corporate one, a connection is needed. The connection is called VPC peering, which enables traffic to be routed privately between the two VPCs. So another beautiful thing about VPC peering is that the traffic is routed using the AWS backbone, its infrastructural backbone, meaning that it does not traverse the internet. So traffic that is passed from one VPC to the other does not go through the internet. It follows the AWS backbone. So there's a way AWS has defined its infrastructure, and that is important, especially if you're trying to send data that requires some increased level of security, and also you don't want it to suffer from latency and stuff like that. So you can use VPC peering. Yes, very, very important. Yeah, peer-to-peer connections. Peer-to-peer connections, that is one peer is a VPC, another peer is a VPC, so it becomes a VPC peering connection. So that is awesome. Thank you. Network management models. That's the next topic, the next subtopic. Network management models. So we start by asking ourselves a question. What is network management? And we answer by saying, a network management model is a representation of how data is managed and how applications are hosted in a network. It is a representation of how data is managed and how applications are hosted in a network. There are 2 most common models for LAN, and one of them is client to server connection, and another one is peer-to-peer connection. So server, you can see here, we have this first diagram that you see here, this one. This is a server. This one represents a server. And then we have a client. So this is a client to server model. And then you have peer-to-peer. You see this one just looks like normal computers, peer-to-peer connections. So that's the peer-to-peer model. Why is this important? it's important to understand a network management model because they define the roles and relationships of device in your network. They define the role and relationship of devices in your network. So the most common for LAN are client server and peer-to-peer. So sometimes maybe in your future, you might get that you have landed this job as a network engineer. Now, as a network engineer, you are tasked with not only managing their cloud infrastructure, but also their physical infrastructure. So when you come to your physical infrastructure, then you find out that maybe one node within your network is not working and it is causing problems. So you might have to replace that with something that works. Then you have to make sure that you have a bird's eye view of your entire network such that you can define the roles and relationship of all the devices that are found in your network so that you know, for example, device A, B, C are my servers, and then device C, D, E. Okay, maybe device A, B, C are my servers. Device B, C, D are also my servers. But now the work of these other servers, the first 3 servers are web servers. But now these other 3 are maybe supposed to be database servers. And then now when you're defining security for them, you'll make sure that you give extra security and restricted access to your database server. You know, you can make your web servers publicly available, but your database servers, you protect them. You protect them properly and make sure that only authorized people can access your database server. Hope that one has sunk in. Then, apart from that, we also have the client server model. So we say that a client server model is mainly for data management and application hosting. So both data management and application hosting are centralized at the server and distributed to the clients. You see, sorry. All clients on the network must use the same designated server to access shared files. The information that are stored on the serving computer. They are stored on the serving computer. So the server will have all those resources, and then your clients will be able to access those resources. But now they have to access it through the server. You see? So we have these clients that are connected to a switch, and this switch is also connected to the server. So if a client, let's say, for example, a client in computer 2 wants to access something from the server, they'll send a request, and then a response will be generated by the server back to the requester. So examples of client model servers are file servers and desktop clients, and print servers and desktop clients. You see, so when you take a file server and a desktop client, that one becomes a what? That one becomes a client server model. And when you take a print server and a desktop clients, that also becomes a client server model. So client server model. And then aside from client server model, we also had a peer-to-peer model. So in this model, each node has its own data and application and is responsible for its own management and security. So it means that each of these computers, they have their own data and they have their own applications. So they take full responsibility of running those data, making sure its completeness, and making sure that it's up to date. That is their work. You know, that's their work. So it's not like they are trying to pull anything from an external database. No, it is self-contained. So peer-to-peer model is distributed architecture that shared tasks or workloads among peers. So if there are tasks that have been given, if computer A is busy, computer B can do those tasks. Why? Because computer B also has the same resources that it needs to execute the task that has been given to that pool of computers, you know. So the model that we've talked about, the peer-to-peer model, might be considered under the following conditions. So the first condition is users are responsible for backing up each node. That's the work of the user. Security requirements are not restrictive, and then a limited number of peers are used. Peer-to-peer connection can become a bit messy if the number of peers are so many. Now, next, after we've looked at the types of connections, next we now move on to look at network protocols. So under network protocols, we start by defining a network protocol and say a network protocol defines the rules for formatting and transmitting data between devices on a network. So network protocols defines the rules for formatting and transmitting data between devices in a network. It typically operates at layer 3, that is network, and layer 4, which is transport of the OSI. You see where OSI is now again important. So you are told that this network protocol typically operates at layer 3, which is the network, and layer 4, which is the transport layers of the OSI model. It falls under 2 categories. So we have 2 categories for network protocol. So one is connection-oriented protocol, and we also have connectionless protocol. You see, those are the 2 main. We have connection-oriented protocol and connectionless protocol. An example of connection-oriented protocol is a phone call between 2 people. One person calls, the other answers, and therefore a connection is established. An example of a connectionless protocol is sending a package through the mail to another person. Once it leaves your hand, the package can get to its destination or it can get lost. It doesn't require a connection to be established. You see, you can send your letters, and then, for example, you can send your letter, and then you want to make sure that this letter gets to where it is going to. So if there is a way for you to ensure that connection is established, you can do this one through other forms of communication. Like we've just given an example of 2 people communicating to each other via a phone call. So when I call you, for example, I'm calling Gideon. When Gideon picks and then I say hello, he says hello, that connection has been established. So whatever I am going to tell Gideon will be received. So I am sure it will be received because I have first of all started by doing what? Establishing a connection between myself and Gideon. But in the other type of example that you've been given, you're told that you've written a letter, and now that you are in the exam period, maybe you can use an example of a success card. You have written a success card. I don't know if they are still sent to date. You've written a success card, and maybe you've even put in kapesa kadogo ya kusaidia candidate akule quarter during the exams. Alafu you've sealed it, and then you've sent it to the poster, make a stamp, and you've sealed, and now you've sent it through poster. You are not sure that this letter will get where it goes. I normally say we started operating in faith from Kitambo, sending a letter and then sitting pretty expecting that it will get where it is supposed to go, and then you will get a response. Back in the day, it used to take some days for it to get where it wants to get, and then you get a response coming back to you. So some crafty people, we have crafty people sometimes, because how do you explain that umetuma success card umekado ndani and then it does not get where it's supposed to get? How do you explain that? Then it means that there was someone in the middle here who did something. We can call it a man in the middle there who did something, and then now the success card did not get where it wants to get. So you see, I'm just trying to show you that in this particular one, it is not like you have, first of all, sent, like, for example, you send a note, you send a small note. You want to try and see if these people are honest. You send a note without money, and then you send it as an envelope. When the person receives it the other side and tells you, but then nimepata hiyo, then now you can send the real one. Nothing assures you that this real one that you sent will still get there. And there are many factors in between here that can make that one impossible to get there. And I'm taking time to explain this so that you understand the difference between connectionless and connection-oriented protocol. Connection-oriented protocol, a connection is first of all established before the data is sent. A connectionless protocol, you release your data and say, liwe liwalo, ifike isifike, mimi nime release. And you'll figure out much later when we'll be looking at the examples of what a connectionless protocol is and connection-oriented protocol is. You'll figure that they differ and they are fit for different use cases. They are fit for different use cases. Hiyo example ya success card imenikumbusha mengi. Siwe peke yako, tuko wengi. I hope your story was better, Gideon. I hope yours was better. I hope ulipata hizo dozi zenye ulikuwa umetumiwa. Mimi, I was just getting guys telling me, wait, after I've done my exam, wanaambia, nilikutumia baka kitu, because I had begrudged them. Naambia mtu, najidai ukinja tuweni anko yangu, alafu hata wezituma kitu, hata ya quarter tu, I remember when I was in high school, quarter was very important. Quarter was very important. Unakosa quarter, unajipata ukiwiso, unajipata ukiwiso. Ati Gideon aliwekewa kitunguu kwa success card. No, not that quarter, not that quarter. Hey, cool kid. Anthony, I can see you, cool kid. No, I mean quarter a loaf. I don't know. Okay, maybe I'm too old, but during our days, we used to buy quarter a loaf pale kwa kantini ya shule. You buy that one and then unateremsha na chai yako ama na uji yako ama kama ni usiku unateremsha na what we used to call cold power. Quarter ya bread ya wa Brian. Brian, quarter ya bread. A quarter a loaf. Si kamnyweso, hapana sio hiyo. What you taught? I can see you. Quarter ya bread. Kwani you guys in your high school, you did not have quarter being sold in your high school? Ama nyinyi wala Britannia. What your biscuit na cookies? What your biscuit na cookies? I can see kina Purity. Oh, ngumu ama KDF. I can see you. Belinda, cheka tu hapo. Cheka tu hapo. Ama nyinyi mko mnauziwa chapo na mandazi. Hey, my friend. I don't know if this bread still exists. There was, okay, it's not really a type of bread, but when you get bread baked and then it is not sliced, we call it buffalo. Back in the day, we used to call it buffalo. That is what they used to cut. Walikuwa nakata quarter yake. So a full bread inakatwa mara 4. Naona watu hapo. What you call power? Elfas, I can see you. I can see you. Ugali ya sapa unabakisha paka asubuhi. You must have been a legend, Purity. You see? So that tulikuwa wapi? Nimejipata naongelea bread nikasahau tulikuwa wapi. We are talking about protocols, but that was a good breather, because pia pen is a marathon kiasi. Yes, so we are talking about those types, and so you can relate, and you can see when you're calling somebody, you call them immediately. Oh, but there another example even before we get back to the notes. Back in the day, I remember, did I ever use it? I don't think so. Kabla itolewe, I never used it. There was something we used to call Telegram. Wachane na hizi Telegram hizi zenye mnatumia kwa simu, sio hizo. I don't mean that one. There was something that we used to call Telegram that was used for communication. So what Telegram used to do, and it was actually examinable. Tulikuwa hata tunaulizwa maswali kwa exam. Unaambiwa you want to send this many, yes, ilikuwa inasetiwa in primary. True, Justin, I can see. So, ni kama typewriter. So you take a message to the post office, then somebody types. Someone types that message and then it is counted per word, and then you are billed per word used. Even a full stop was counted as a word. So, and it's interesting because I don't know because pesa kitambo ikuanga expensive kama leo, ama it depends on that situation. Yes, slim na karefu. So I don't know what used to happen, but you can say, let's say for example, you are in boarding school and you'd like to send information to your parents at home. You can say, me sick, send money. That's even long. You have to find a way of now making it even shorter. Me sick, send money. Those are many words. You need to make it shorter than that. Because I think it was counted per character. I don't think it was per word. Maybe it was per character. So guys were really trying to make sure that this information is so short, so that you don't spend a lot. So that there was that. And this one, when you type it here, it is received in the other end. It is received in the other end. Let's say, for example, I'm sending it, I'm in Kiambu, I want to send it to Eldoret. It is received in Eldoret, and then now it can be communicated to the person that you want to receive it. So it was a clever one. It was a clever one. It was a very clever one. So, Justin is saying never saw one, but used to calculate them like a poster office. Yeah, officer, like a poster officer. Very nice. Awesome. Yes, awesome. So those are just types of communication. And you see, every communication we talk about, including phone calls that we make today, including sending letters, including using the likes of a typewriter, all of those, when you look at them, they are the thing that they were sending is still the same to even what you're talking about our modern network today. They were all sending data in different form and formats. In different forms and formats. Today, it's possible for you to just pick a call and call someone and get an immediate response. You know, today it is also possible for you to just write someone a message and they get it in real time and respond to you. You can even jump in a call such as this one, a video call, and call somebody and talk to someone in real time. You know, in real time. Like Saizi, you can just decide, I have a friend in the US, and say, I want to talk to this friend, and maybe they are awake. And then you just jump into a call and you talk. You see, you talk. And WhatsApp call is also there for us, that you can even make a call, talk to someone in the UK, talk to someone in Europe, talk to someone in China, and you're just good. You see, you're just good. So communication has evolved, and that is what we talk about. Everything that we talk about is what we call data. Is what we call data. Yes. Now, looking at connection-oriented protocol, when we ask ourselves the question, what is connection-oriented protocol? So this is a protocol that establishes a connection. A connection has to be established first. It awaits a response. It creates a session between the sender and the receiver, and it uses synchronous communication. So a connection-oriented protocol works similar to a person calling another, the way you've just described it, person, and they answer. The connection is then established. Let's say, for example, I have information that I'd like to communicate to Justin. I'll call Justin. First of all, ukipiga simu, you normally hear the simu, your dial tone. Or kuna wale wenye wameweka nyimbo, maybe wameweka wimbo kama wameweka sijui zinaitwa callback tones ama nini, things like Kinanguka Nayo and stuff like that. Maybe they've subscribed to that. So wameweka kwa masikio, you hear that. And nowadays people are a bit funny. You can even hear things like, oh, sijui, I'm not available at the moment. Kuna appear to a voicemail. But sasa, if it is a matter of you trying to make a connection, I first of all wait for Justin to pick his call. Yeah, they're called Skiza tunes. Thank you, Musembi. They're called Skiza tunes. So I'm trying to talk to Justin. Then Justin picks up. Once he picks up, I'll start by salutation, because that is proper protocol or good manners. Salutation, ukoje, niaje bro, ukoje, unaendeleaje, blah, blah, blah. You see, that in English. What is Skiza tune in English? Hearing tunes. What is Skiza tunes in English? Skiza tune, I think Skiza tune is like M-Pesa. It does not have an English name. Or what is M-Pesa in English? And don't tell me mobile money. No, mobile money is a generic term for all of them, including Airtel money. You know, listening tunes. Skiza, listening tunes. That's a clever one. You know, so I'm saying, once Justin picks my call, then I have established that connection, and we've talked, and I have found that he's okay. Then I can now give him the information. Maybe my information that I want to communicate to him is tell him, by the way, there is this lab that you've not done, and I'm going to have a session with a few of you tomorrow night. Will you be available, and would you like to be included in the session, so that I send you the link? Then it tells me, yes, I am available and I will be interested in the session. So kindly send me the link. Then I'll be sending the link. What has happened there? First, I established the connection. Secondly, I have now passed the information. And thirdly, I have received a response from him. You see, that's what we call connection-oriented protocol. Then, from connection-oriented protocol, I'll leave these notes for you to read. It is something that you guys can read with ease, because you guys are smart. Na kama kawaida, if you run into any, let me see something. I'm Googling something. Yeah, so synchronous communication, which I saw is part of our connection-oriented protocol, is a real-time exchange of information where all participants are present and interacting at the same time. You see, synchronous communication, a real-time exchange of information where all participants are present and interacting at the same time. So I am interacting, say, with Justin in the example that I gave. We are talking, I am talking, he is answering me, I am getting feedback. You see, I ask a question, my question is a request, he's giving me a response, and then I give a follow-up question, if any, or I give further instructions, if any, you know, if any. Then Dan is asking for asynchronous. Let's see what asynchronous is. Asynchronous communication is a method of communication where participants interact at different times rather than in real time. At different time inaweza kuwa ni hivi. Maybe maybe done, you in the process of time you've graduated from this program, and then now you have gone maybe freelancing, and then you have found this client, and this client is in a different time zone, and now the best way for you to communicate with this client is maybe through the likes of chat. Sometimes you send someone chat maybe on Upwork or Fiverr, and then they answer you when they are awake, so you're not communicating in real time. You're not communicating in real time. You give your part of the communication, then you wait for feedback from them, or you wait for response from them a bit later. No, a bit later. So this one involves sending a message and not expecting an immediate response. Though sometimes you are lucky, sometimes you might be thinking that it is their nap time, na kumbe hiyo ndio siku yenye nini yenye usingizi imekataa. Maybe they are online at that time, or they are working late. Then they surprise you with a response in real time. So if it becomes real time, it turns from asynchronous to synchronous. So aside from text, yes, very good, very good, very good, very good, Gideon. Aside from text messages, we also have emails and pre-recorded videos. So and sometimes we even have pre-recorded audios. Sometimes I have this client that I used to work with back in the day. He was in China, and so sometimes I wake up in the morning and then I find that they've sent me a voice note over WhatsApp. So I listen to the voice note and then I respond. But I'm wondering why I've never sent them a response in voice note. I normally respond in text. I think I'm just wired for texting. No, I don't know. Well, I'll interrogate. I will introspect and understand why. The Chinese are very good. Yeah, it's very true. I've worked with Chinese and Australian clients. They are amazing people to work with. They are amazing people to work with. So lucky when your ratings are good. Yes. So again, we'll be talking to you guys about freelancing, because we told you guys that we really want to make you guys to be employable, to be work ready. To be work ready by the time you'll be getting out of this course. So at some point, we'll be talking to you guys about freelancing as a route that you can take. And I normally tell guys this, that IT works. If you get a good and understanding client, IT is based on deliverables. It's not about the hours you clock. It's not a matter of you entering into an office at 9 and leaving at 5. No, it's a matter of you having been given work to do, and then you deliver it on time. On time and according to the expected quality. So it is possible for you to have like 2 or 3 clients at the same time. You can have a full-time job and have a side gig, maybe serving clients as a freelancer. I do a lot of freelancing work, na hapo mtu kwa chat asiniambie nimpatie kazi. Pia mimi bado natafuta zingine. So it is fun. It is fun. It's really fun. So social media such as WhatsApp, let me see. Social media such as WhatsApp, if the replies are fast, is that synchronous? So synchronous, you had, okay, strictly speaking, you had when we defined synchronous, we said that this is a method of participation where the two, let's say Mimi, now we are talking at the same time, we are chatting at the same time. I'm sending you like, hi, like today, over the break, I was talking to guys in my channel and I was telling them, hi, at so and so, kindly join your channel. And then they join and then they tell me joined. That is synchronous. When you talk about it to Vileiko, the way because you're getting your response almost immediately. But if I drop you a message and then you take time, you'll answer me later, that's now asynchronous. Same thing too. I call you and then I find that I'm redirected to a voice to a voice. Voice this thing that records me when I call. What's the name of that thing? Voicemail. Yeah. I'm directed to voicemail. Then it is recorded. Then you come back like an hour or a few minutes later. Then that's when you are hearing what I had to say, and then you call me back. That one, the first instance of our communication was asynchronous, because I did not establish a direct communication with you. Your voicemail does not qualify for you, the person. You the person. What about walkie-talkie? Is it synchronous or asynchronous? I believe it is synchronous, because if it's walkie-talkie, the ones that you talk about, lenye unasikia polisi anaongea anasema tuko hii area over, and then you anasema na sisi pia tuko hiyo area ingine over, that is over. Okay, we used to call them over because of what they say over. So so that is also synchronous. Thank you for that. The reply is immediate. Yeah, that is true. That is true, Justin. Then Chinese are good pale Upwork. My experience with Australian was hectic. Kwanzaa or Melbourne. Problem with Australians, for me, it was the time zone. But Mimi, I am well aligned. I can work across different time zones. I can work as a night owl. Actually, I really like working at night when chances present because of the quietness. Yeah, alafu mi I can sleep hata mchana, sinanga shida. Then lakini Kenyans hapana afadhali other countries. Kenyans are difficult to work with. Same experience. Rage with Kenyans utainama hadi uchoke. Just know, when we'll be talking about freelancing, we will also give you our own experiences. We'll also give you our own experiences, and we'll also give you hacks of how to deal with the clients, because they are being conned by freelance, being conned around freelancing space is also real. Inaitwa character development Promax. It is also very, very real. So mwingine nilirudi proposal akaingia, niliunda proposal akaingia maji, wako tu hapo. Usikia anasema send as fast as possible. You guys share those remote opportunities. We will in due time, in due time. In due time we will. Say, get the knowledge, guys. Get the knowledge. Good. That was good. So that is for connectionless, and then I'll leave you to read those notes. And then now, that is for connection-oriented protocol, sorry. Now, for connectionless protocol, what is connectionless protocol? We say that it sends a message from one endpoint to the other without ensuring that the destination is available and ready to receive the data. You know, you are not sure. You are not sure that the destination is available and ready to receive the data. Oh, unatuma tu quick fire. It does not require a session between the sender and the receiver. It uses asynchronous communication. So most of these texts that we send, oftentimes, when we send text, we are not really sure that that connection is still there. Like, for example, I'm sending you a WhatsApp message. I'm not sure if your network is on. I'm not sure if your phone is on. I'm not sure if you even have that phone. Maybe ulikuwa umetembea pale CBD, mtu akaamua jibless nayo. You know, maybe you don't even have a smartphone. Maybe you had it yesterday. Today you're back to Kabambe. But me, I've just sent you a message. Sisi tunaombea watu mabaya. I'm just giving you an example. Something that has happened to me before. So don't worry. So when it becomes connectionless, at the end of the day, you are sending this and you are hoping that it's like you're sending a message hoping that the person receives it. But it works, and I've told you that we will look into where connection-oriented protocol is needed and where connectionless protocol can also do very well. And you'll be surprised. There are some applications that you're using today that are either using connectionless and others are using connection-based protocol. So you don't know if the receiver is available or not to receive it. It happens and synchronous. So now they've used an example of sending a letter. You know, you're sending a letter to somebody, you're not sure if they will receive it. Sometimes I've seen this in movies. Mtu ametumiwa letters kadhaa, and then these letters have been delivered to their house, while at the same time these guys had even traveled for holiday 3 months. They come back 3 months later and find so many letters. When they open the door, they find so many letters greeting them hapo chini, and now maybe there was something urgent that needed to be attended to or stuff like that. So again, you will read this. Yeah, I think this example is important. An example of this is like sending mail. You mail a letter or package, and once it leaves your mailbox or post office, it is asynchronous between the sender and the receiver. The party isn't readily available to receive the package, and you won't know exactly when they will be. You just send the mail hoping they will get it. Hoping they will get it. Mailboxes, yes. Awesome. So, so there are 4 examples of protocols that we are going to focus on in this class. So those 4 examples include Internet Protocol or IP, Transmission Control Protocol or TCP, TCP/IP, which is a combination of Internet Protocol and TCP, and then you have User Datagram Protocol, UDP. It almost sounds like a political party. UDP. Internet Protocol. Let's look at Internet Protocol. So IP establishes the rules for relaying and routing data in the internet. That's the work of the internet protocol. It establishes the rules for relaying and routing data in the internet. That's about IP. Transmission Control Protocol, TCP, provides a reliable connection-oriented. You see that word? A reliable, connection-oriented, and ordered delivery of bitstream over an IP network, that is TCP, provides a reliable connection-oriented and ordered delivery of bit streams over an IP network. Then you have TCP/IP. TCP/IP, when TCP and IP are combined, they form what we call the TCP/IP protocol suite. TCP/IP implements the set of protocols that the internet runs on. When you combine the two, transmission control protocol and internet protocol, they provide a set of protocols that the internet runs on. Then you have the user datagram protocol, UDP. UDP uses a simple connectionless communication model to deliver data over an IP network. It is unreliable because it does not guarantee the delivery or ordering of data. It has lower overhead and is faster than TCP. No, sorry. In as much as it does not guarantee you delivery or ordering of data, it has some positive. One, it has lower overhead, and two, it is faster than TCP. So this is why it is appropriate for some use cases. You'll find that UDP is fit for some use cases. And shock on you, use cases such as things like gaming, online gaming, and movie streaming uses UDP. Online gaming and I've said online gaming and video streaming uses UDP, and we will see more about that. I believe, is it in this course or in the next one? Let's see. So let's read through these notes together. TCP/IP is a connectionless oriented protocol, and it defines how to establish and maintain network communication in which application programs can exchange data. So here, data is sent via this protocol. Data that is sent via this protocol is broken down into smaller chunks. The chunks, we talked about them in the morning, and we called them packets. The goal of TCP/IP was to support an interconnection of networks. That was the goal. The original goal was to support an interconnection of networks called the internet. TCP alone is great for transferring important files since there is guarantee of connection, even though there's a larger overhead. And there's a larger overhead. When we are talking about overhead, we are looking at it in terms of time. There's a larger overhead because first it has to establish connection. Wait first and make sure that the connection has been established before these important files are then transmitted. Before these important files are then transmitted. So that is very, very important. With TCP, there is something called TCP handshake. Handshake, TCP handshake. This handshake is comprised of 3 messages. Number 1 is SYN, which stands for synchronize. Number 2 is synchronize/acknowledge, or sync ACK. And then finally, it is acknowledge. So we have sync, sync-ACK, and sync-ACK and ACK. During this handshake, the protocol establishes parameters that support the data transfer between 2 hosts. Let's look at an example. So, in the example that has been provided, host A sends a sync packet to host B. Host B sends the sync with an ACK attached to acknowledge that they have received it with a message back to host A. You see? Then host A sends the last message with the ACK to host B, letting them know they have received the sync ACK message. You see that? So the first one, we have these 2 hosts. We have host A and host B. So one thing that happens is that host A, when sending the packet, starts by sending what we call a sync packet to host B. Once host B receives, ni kama host B receive, host B signs that have received, and then sends back this signed sync packet with an ACK attached to it to acknowledge that I have received it, and this message goes back to host A. Once host A receives, host A sends the last message to acknowledge to B, letting them know that they have received the sync ANK. So I was sending something to, let me see, who can I use as an example? I was sending something to Rich, for example. I was sending something to Rich. Now, I send a message to Rich. Rich receives, let's say, for example, it's a document that I need his signature on. So I send it to Rich. Rich receives it. Rich sends it, signs it, and sends it back to me. Once Rich has sent it back to me, I countersign it. You see, I sent it with two places to sign. I have not signed it. I've sent it to Rich. Rich has signed it and has sent it back. So it shows me that Rich has acknowledged that there is this agreement between me and him he has signed. So once I receive it, I sign it. After I have signed it and now it bears both of our signatures, I now send a copy of it to Rich for his own documentation or for his own keeping, so that he has a copy of our agreement. So it is the same thing that you see here. Host A has sent a sync package to B. B sends the sync with an ACK attached to acknowledge that they have received. Then A sends the last message with the ACK to B, letting them know that they have received the sync ACK package. I'm staying here for long because one thing that you are going to meet, and this one I assure you, if you are going into the networking space or any role in the cloud that requires networking, because almost all roles, including cloud engineer, requires networking, don't be surprised when you're asked a question. When you're asked a question about TCP and UDP, can you distinguish between TCP and UDP using examples? You see, using examples. And then number two, you can get a non-techie HR who asks you, can you now help me understand TCP and UDP as if, okay, knowing that I'm non-techie, explain to me TCP and UDP as transfer protocols, as networking protocols, but use non-tech terms. So you see, I've already given you a hint of what you can use. You're saying, I send, if it is a matter of UDP, UDP is connectionless, meaning that I don't need to establish what? I don't need to establish a connection before I send the entire document. No, I don't need to establish a connection before I send the entire message or the entire data that I need to send. But for TCP, you tell them that this one is connection oriented. So first of all, I have to ensure that the receiver of this entirety of communication that I need to make have first of all present to receive it. Then once I've sent the first bit and then they have acknowledged, I send the rest to them. I send the rest to them. So that is very, very important. Atuambia TCP handshake ni kama kukatiana to sync. Client asks to start a connection, proposal, girlfriend. Sync plus ACK. Server agrees and replies, acceptance. ACK, client confirms relationship. Okay. I can see what you've done there. But just Jua, the most important thing for you guys, especially now that you're coming to the cloud space, maybe even your starting role is that of a cloud engineer, alafu na ambayo you'll be working as a solutions architect, even without the certifications as yet. Solutions architecting is that role that requires you to do a lot of communication with clients. You'll be client facing. And being client facing, it means some of these clients are not techie. They're not techie. So you'll need to find a way of making them see sense of the solution that you're proposing. Maybe they want to migrate their servers to the cloud. You have to make them see sense by you explaining that when we do this, it will happen like this. Or they can even hit you with some funny questions, like question of access. How am I going to access it? Wanaweza kuuliza pia swali ya learning curve. How will my small IT department learn how to use this new solution that you're proposing? Stuff like that. So you have to really know from Kitambo, you need to know how to bring these concepts, how to bring them to your clients in the easiest way possible, so that they will be able to understand what you're talking about. I hope we are together up to Hapo. I hope you are together up to Apple. And thank you for that. Thank you for that analogy, Musembi. That's good. UDP, we've said, again, we've just said that UDP uses connectionless communication and there is no guarantee of delivery or ordering of data. So when you're talking about ordering of data for TCP, the order in which you send the data, remember, you can be sending data in batches or in what we call packets. So the ordering is important. You see, the ordering is important. So whatever is received, let me see if I can get that. There was like a good meme. Let me see if I can get it first. TCP. Let me see if I can get it. Mhm. Mhm. Just a second. Mm. So there is this one from Reddit. Let me show you this one. Umefunguka kweli. Give it a second. You see, you know that there is a bed here, so the bed will receive the baby vizuri. Now, you're assuming that there's a bed this side penye it is not shown. Mtoto ndio amerusha naambiwa go sleep oh. Go now sleep. Now, please don't try this at home. If you have little ones, please don't try this at home. And then say that I learned it in class. Please don't. So this is this one of those examples. Let's see another one. There's another one. Where is it? Where is it? Where is it? Let me see. Let me see. Mhm. If you have a meme that shows TCP and UDP, also feel free to share. Yeah. Also feel free to share. Let me open this other one. Mhm. Mhm. Ai, unakata kufunguka kwa nini? Still from the same guys hapo Reddit. Watu wa kukunywa maji ama uji, I mean the real uji. Watu wa maji, and here I mean water. Lest Musembi misinterprets what I'm saying. TCP versus UDP. Unaona TCP? Maji kwa mdomo directly. UDP, unafungua mdomo, maji can miss, maji inaweza gongata mapua. You know? You see that? Connection based, yengine ni connectionless. Stuff like that. Then finally, I saw something else. I saw something else. Let me see. Where is it? TCP, UDP. Let me play it first. Hata kuna za ovyo. Advertisements kila mahali, hata kwa TCP, UDP. Let me show you what we are going to do here. Ai. Wewe. Musembi, umeamua? Musembi, umeamua ni... Okay, let's see. Let me see if I can get that thing here. I have a very interesting browser I use. This one by default, it does the things that I want it to do. So give it a second. That's not what I'm looking for. Let's see. Mhm. Am I getting what I want? Watch again. Yeah. That's a very good one, Musembi. Letter delivery. So let me share this. This is very short, and maybe you guys can watch this one, and I'll also give you the link to it. Let me pause. Let me reshare so that you can also hear, although there's no explainer, but no, I know what I'll do. So for this one, I'll pick the link first, then I'll give you guys the link, the chart, UDP versus TCP. That's the link. So you can save that link and watch it later. But now I can play it here without, you don't need to listen to the audio because there's nothing that they are saying really. So let me make it larger. That's the largest it can be. Okay. So watch that. You see TCP, sync message sent. UDP, nothing is being sent as yet. After the acknowledging, the data is broken into packets and then it is sent. And to focus on the order, see that? You see? So the first one goes, and then now it has been finished, acknowledged, and then everything ends. But let's replay it again. Sorry. Why is that? Yes, let's replay it again. You see, this one, and to pay attention to UDP. So we have the header, everything is going in 2, 3. Once it is received, then if an answer is going to be given, it will be given directly from the receiver. It does not wait for anything. So you see what this one does. This one communicates, the communication continues, but for this one you send and then you chill. Nothing else happens here. So maybe you will watch this and this one will make much sense. You can see for TCP, we have the acknowledgement and even we have the the finished, meaning that the receiver says that now, have you finished? And then sender says, yes, I've finished. And then everything now ends there. You see, everything ends there. Look at that. Finished, finished, acknowledged, acknowledge, finish. You see, so that is what I wanted you guys to see. And I hope that one has solidified your understanding of what we mean when you're talking about TCP, UDP. So now, moving on, down here, we just have whatever we've been discussing now further elaborated, where we are talking about transmission control protocol, TCP handshake. This is connection oriented, as we say. TCP handshake comprises of 3. We talked about the sync ARC, and the ARC. So we start host A sends the sync, host B sends the sync ARC, host A acknowledges, and then everything continues. During the 3-step handshake, the protocol establishes parameters that support the data transfer. So this is the handshake legit. And then, why is this all important? Why is us understanding TCP important? So when you're troubleshooting, you can choose tools like Wireshark or TCP dump. These are tools that are used to test networks and connections, Wireshark or TCP dump on Linux machine to understand whether your packets are getting lost in communication. By understanding the flags and where they stand in each process, this will allow you to troubleshoot the issue of where the issue may lie. You are now troubleshooting to find out where the problem may lie in your network, So TCP is great for transferring important files since there is a guarantee of connection, even though there is a larger overhead. Sometimes you might say that that overhead does not matter depending on the importance of what you're trying to transmit. And in other applications, that overhead is a concern because what you want to happen during your data transfer, you want almost real-time delivery of the packets. Sorry, that is why you find that UDP works very well for things like, sorry, gaming and video, magic dogo. Gaming and video streaming. You wouldn't want to be playing your COD, Call of Duty. You're playing your game online with friends, and then when that drag, and then by the time the data that you are expecting kufikie, you've already been shot. You know, so you want that near real time delivery of packets of data. You know, that's very important. So we say that TCP is connection oriented, and with TCP, there is something that we call the TCP handshake, and we've talked about the sync ACK, and the ACK, where ACK stands for acknowledge and sync stands for synchronize. During this handshake, the protocol establishes parameters that support the data transfer between the two hosts. And we already talked about this process of A sending, B receiving and sending something, A sending the rest of the message. That one we talked about. There is also a process where it gracefully closes the communication between the sender and the receiver. And this is something that we did not see qua slides, but we've seen it in that short clip where we were seeing that it was sending the fin, FIN, finished, and then the receiver acknowledges by sending fin ACK, and then the host or the sender sends the ACK, and then now it is gracefully closed. Yeah, gracefully closed. So we have fin for finish acknowledge, fin ACK, and acknowledge. So there is also something called reset when flags, reset flags when a connection closes abruptly and causes an error. So RST is a flag that that is released by either sender or receiver when the connection closes abruptly and causes an error. So it is not that every time atinafundisha kutumia Wireshark where that is beyond how do we call it? That is beyond this lesson. It is beyond this lesson. Saizi nikianza kufundisha kuhusu Wireshark, watu watatoka, beyond this syllabus, it's beyond. The man I was inviting guys who are interested to do networking deeper. Maybe you can go and consider doing the CCNA course. So when you do CCNA now, when you get a bit deeper, or CCNA also has a course on ethical, how do you call it? A course on ethical hacking. One that I'm yet to start, yet I'm registered, but I'm yet to start. So under ethical hacking, you'll get to use the likes of Wireshark. So Wireshark is very, very important. Here in your cybersecurity mostly, huko ndio utasomea Wireshark. Yes. So if you are security focused like myself, I am heavily security focused. So that's why I do a bit of cyber, but my ultimate focus is actually cloud security. So all that you will meet them there, Msembi. So if you're interested, tembea pale kwa Cisco, and I think it's called Net Academy. You will get that course. Let me check something. So success in most of these things depends on your ability kujituma. Depends the ability kujituma. And remember, we had already offered together with Joy to guide you guys, because you know that all of you are starting as practitioners, but people will take different routes. You know, people will take different routes, and it is okay to take those routes. You know, it's okay to take those routes. So let me show you something that I've just found. I just went to Networking Academy, and you can see they have a course on Introduction to Cybersecurity, Ethical Hacking, Junior Cybersecurity Analyst. All of these are available. Yeah. So if networking is something that you fancy, CCNA is a good place, or rather Cisco is a good place to go and try do that. Enroll kwa Cyber Shujaa program, matters of security ziko huko. Interesting. I've actually done like two sorry, 2 Azure certifications in Cyber Shujaa. That's good. That's good. So my focus is packet sniffing. Yeah, packet sniffing. Are you planning to be MIM? Man in the middle. Are you planning to be a man in the middle, Musembi, tukuseme mapema tu saizi? Remember there is a cyber security act. I don't even know how that act is called in full, but there is that one. So please tend towards the positive side of the law. Good money never comes clean. It does. I think it does. Then that was TCP. Now let's look at UDP. User Datagram Protocol. Let me see how we are doing on time. Not very bad. User Datagram Protocol. So under User Datagram Protocol, nice, awesome, nice, Hassan, nice, very, very nice. So User Datagram Protocol. Here we already say that this is connectionless. This is connectionless. It does not wait for the connection to be established. So it has lower overhead and it's faster than TCP. It is connectionless and there's no guarantee all your data will get there or in order. UDP, data flows from one computer to another. There is no sync or ARC. It cares about speed more than ensuring data gets to computer B. So it is more focused on speed. It does not really care that data has gotten where it's supposed to get. It sends speed fast. So UDP uses connectionless communication, and there's no guarantee of delivery or ordering of data. The best example and use case for UDP is media. When streaming services such as movie, UDP is used. It is fast. However, there are times when you might see buffering and things may seem off or out of order, like the words do not match up to the picture. So when you see that one happening, jua kulikuwa na possibility that nilipotea mahali, some data nilipotea in the transmission. That is UDP delivering the data, and the streaming service trying to order the data as UDP does not guarantee the order of delivery. It is like umepika ugali mboga, and then or you've ordered. Hey, is that possible really? You've ordered ugali from Hotel A, you've ordered mboga from Hotel B, hoping that ugali will arrive before mboga, then mboga arrives before ugali, stuff like that. That example, I don't think I can make. Like, scratch that. Like, and things may seem off out of order, like the words do not match. I think you've seen this, especially if you are watching, I don't know how many of you guys watched Money Heist. There's a movie called Money Heist that came out, and I think the original one, before yenye kona English, ilikuwa na subtitles in English. And then when you try to read the subtitles and you are trying to look at what they are saying, it's like different, man. It's like different. They're saying other things. Like if they are saying that it is like, let's say the professor speaking, but when you look at the lips of the person that is speaking, maybe it's Nairobi that was speaking, stuff like that. For those ones who watch movies, that is. I hope that example is relevant to most of you. It's about speed and does not provide three-way handshake to ensure data is delivered. It has minimum set of functions and is considered unreliable compared to TCP. So you've seen that it has limited functions, but that is what that's what UDP does. So you've seen UDP, you've seen TCP. We've talked about a lot of things since we started talking at 2. It's now almost 4. So yeah, checkpoint questions. Which area network connects devices over large geographical area? Tumeruka tukaingia checkpoint questions. So someone tell us which one. Dan is saying 1, Sandra is saying 1, Gideon is saying 1, Clinton is saying 1, Gail is saying 1, Frank is saying 1. Okay, so all of you agree it's 1. I agree. Then, which type of protocol ensures that a connection is established? What is an example of 1? Which type of connection ensures that a connection is established? And what is an example of 1? We've just talked about it, not kitambo. Yeah, you've given me the example, but which type of connection is that? Those are 2 questions in one.
Connection oriented.
Yes, good. Who was that?
Sharon.
Good. Thank you, Sharon. Thank you, Sharon. Yes, it is connection oriented. It's connection oriented, and an example there is TCP. That is very, very good. Yes, yes, yes. Connection oriented, and we have TCP. Okay, TCP. Yani question one inakaa ni rahisi sana mpaka hata wamekataa kujibu eh. Wameacha tu blank, but we already know it's one. We already know it's one. So that's good. Now, who would want to read for us these key takeaways? The first person, just unmute and read. Key takeaways. Key takeaways. Nani hajaongea leo? Anybody?
Okay, let me read.
Yes, yes.
So a local area network, LAN, connects devices in a limited geographical area, and a wide area network, WAN, connects devices in a large geographical area. A network management model defines how data is managed and how applications are hosted in a network. Client server and peer-to-peer are two common network management models for LAN. A network topology shows how nodes connect to each other. Star and hybrid are example patterns of a network topology. A VPC is a virtual network that allows you to launch AWS resources that you define. A VPC looks and works just like a normal network within a data center, and the benefits of using AWS services for scalability. A network protocol defines the rules for formatting and transmitting data between devices on a network.
Awesome. Thank you so much. Thank you so much, Felix. Thank you so much, Felix. That was awesome. So that's our key takeaways. Those are our key takeaways. And I don't know if this one is still running. It had expired, but at least we're in that page so that I can show you something. So when we are talking about VPC, we say that the VPC by default you will be getting every time you create an account, you have one default VPC per region. You understand? You have one default VPC per region, and then you can create 5 other VPCs per region. Remember, we said that the maximum number of VPCs that you're allowed is actually 5 VPCs per region. So that is very, very important. Now, when it comes to VPC, and you create a VPC when you're creating your instance, so you can create your instance. Like here, I was trying to create an instance called test instance. I've selected my AMI, and then instance type, I've left it as is at T3 micro. Then you will create a key pair. I did not create because I just wanted to show you guys how VPC is created. You come here under network settings, there'll be an edit button here. So you click that edit, then it will open this dialog box where you can now change what you want. So here you can actually create a new VPC. You can create a new VPC. That option is no longer available to us because this session has been terminated, but you can actually create a new VPC. And then for subnet, you can define your subnet. You see, you can define your subnet, or you can create a new subnet. You can create as many subnets as you need. If you need 4 subnets, you can create them. And then availability zones. Yeah, availability zones, you can then check the availability zones that are available to you. You see, we have all of these. We have US West because we are creating this in Oregon, which is in US West region. So you have availability zones as 2A, 2B, 2C, and 2D. And then security groups, you can create a security group, or if you had created one before, you can select it by using select existing availability zone. Again, by default, we have Launch Wizard 1 as a default security zone, a security group, sorry. And then all these other things continue as is. If you need to allow any traffic, let's say to HTTP, you'll come and define it here. So we will do a lot of this when we do deep dives from, I think, week 5, 6. Kuendelea. So we'll be doing a lot of this, and it will become second nature to you guys because it will be something that you guys will be able to do over and over and over again. I know by this point, most of you already know how to comfortably launch an instance, and SSH to it, whether it is on Mac, it's on Linux, or it is on Windows. So if you can confidently say that this is a question. If you can comfortably say that you can create an instance and SSH to it without any problem, let me see you raise your hand. Let me see you raise your hand. I'm doing that so that I can go to the KCs. Raise your hand and keep it raised. Raise your hand and keep it raised. Now usidanganye. Kama huwezi, if you're still facing challenges, I want you to look at those hands. And for people in my group so far, in my group right now, you know, in my channel right now, you know that you're in those small groups. If you see someone has raised their hand and they're in your channel and you're struggling with anything, reach out to them. We are trying to encourage peer-to-peer learning, which is very, very important. Peer-to-peer learning is equally important. It's equally important. Raise those hands and keep them raised. Raise those hands and keep them raised. I'm seeing 21 hands and we are about 40 people in this call. If you subtract the two of us, me and Esther, we are like how many? We are like 38. So I'm seeing 18 out of 38. Where are the 20? Raise them up and keep them raised. Raise them up and keep them raised. Raise them up and keep them raised. I can see Angela. I can see Amy. I can see Gail. Gail. Purity. Surely. Okay. Kuna watu wako wamesikia swali yangu. I've asked and I'm repeating. If you can provision an instance or if you can create an EC2 instance in an AWS account and SSH to it and even run basic Linux command like pwd, make directory. If you can do that comfortably, raise your hand. That was the question. Hassan, na vile nimeona umefanya labs kaa zote. Hassan, nakuona. Hassan, nakuona. Please raise your hand. Please raise your hand. That was the question. Kumbe watu wako wamesikia swali. Watu wako wamesikia swali. If you can't, it's still okay. It's still okay to be honest. It's still okay to be honest because we want to help you at the end of it all. Evans, really? Evans, kwa call. Let me just confirm. Evans, are you in this call? Kiprono, are you in the call? I'm seeing 28 hands. So kuna watu waliingia tu session na wakaenda shughuli. Hivi ndio vile tunashikanga watu wenye hawako session. Raise your hand and keep it raised. I've seen 31 people. Nani anasema yuko Kiprono?
Yes.
Oh, uko area? I hope you heard my question.
Yes, Nico.
Good. I hope you heard my question, people. Keep your hand and keep it raised. These hands are for people who are telling me that part, I am able to create an instance and I can comfortably SSH to it. And there's a reason why I'm looking at these hands. Mark, Befalin, there's a reason why I'm looking at these hands. Juliet, I understand. Wewe naelewa vizuri. And we'll be doing some support sessions for you and for Mary because you guys joined us a bit late. Alex Gathuru, you're in my channel. You have not approached me to tell me that you have a problem in that sector. So I'm wondering why I'm not seeing you there. Alex Evans. Befalin, you're also in my channel. I'm expecting to see you guys. So this is the thing, You know, the knowledge that you guys are getting up to this point is cumulative. So mtu asibaki nyuma. Just keep those hands raised first. Keep those hands raised. So mtu asibaki nyuma. So if you are struggling with that particular task of creating an instance and SSHing to it, just reach out to your channel lead. Give me a second. Keep those hands raised. Give me a second. Okay, so nilikuwa nasema please talk to your channel leads. You can talk to me or talk to Joy and we will help you guys. And then for those who are in the smaller groups, like in my group, just make sure you do what? Just make sure you also talk to your team leads. You know, Make sure you also talk to your team leads. Musembi at 20 bado, 20 bado. You know, you agree that you have given me up to 5, but see at ndaweka hapa mpaka 5, by the way. I don't mean that. Sorry, I don't mean that. Don't mean that. I just want us to do the cases, then you guys can go. Is that okay? Just the KC and then you can go. You can now raise your hands. Thank you for those hands. And raise them. Then let us do this KC. Haraka haraka then mwende. Ndio nisisikie mtu akona excuse anasema ati yo sikufanya KC because of ABCD. Sawa? And some people in my channel I'll be reaching out to you after this call because I am not impressed with the way your KCs have blanks and your labs. So we need to work on those things. We need to work on those things because things are getting heated. I'm looking for that KC. It's this one. And you see from tomorrow we are going back to labs. So leo ndo hamna lab, but from kesho there are labs. Justin and the 5 others, you can unraise your hands. Thank you. So let's do this KC haraka upesi, then you guys can go. Msembi kawa umechoka, mimi mwenye nimeongea since tu. Tunachoka tu lakini kazi mpaka ifanywe. Okay, let's go. So, Musembi, tuanzishie hii. Read for us that question.
Local area network LAN and a wide network one. Can you hear me?
Yes, now we can,
Which statement of the function of a local area network LAN and a wide area network one? Option A. A LAN connects nodes and hosts in a geographically limited area. A WAN connects multiple LANs to create a more expansive network that can cover large geographical areas such as cities. Option B. A LAN is used for wired networks, but WAN is used for wireless networks. Option C. A LAN connects nodes and hosts over a large geographical area. A WAN connects nodes and hosts within a geographically limited area. Option D. A LAN connects servers, but a WAN connects computer devices.
So, of those options, what is the answer?
Option A.
Option A. A LAN connects nodes and hosts within a geographically limited area. A WAN connects multiple LANs to create more expansive network that can cover large geographical areas such as cities. That's awesome. Let's see. Correct. Question 2. Let me read this one. Consider the similarities between traditional network topologies and AWS services. Which of the following is not an AWS service compared to traditional network topology if these similarities are compared? So first, we have security groups and network access control list, network ACLs. Then we have AWS Transit Gateway. Then we have route tables. We have internet gateway, and we have subnet. So which one is not? Which of the following is not an AWS service comparable to traditional network topology? Yeah, sure. Mnasema, Frank, what were you answering? Frank was answering the first question. So mnasema B, Gail anasema B, Ivy anasema B, mnasema transit gateway.
Yes.
Fingers crossed, but I think you are right. You are right. But you'll see transit gateway is also part of networking, but it does a different thing compared to all the others that you've talked about. So, which is the most common hybrid topology used today? Which is the most common hybrid topology used today? Is it mesh, bus, star, or star bus? So you guys are saying D. Okay, let's see. Star bus. I think that was captured in our notes, and that's correct. Number 4, someone read for us. There is no someone in the call. Yes. Please read.
Which statement describes a connectionless protocol? It is known for its reliability and large overhead. It will wait for a response from the destination when the data is sent. It sends a message to the destination without ensuring that the destination is available. It is known as a transmission control protocol, in bracket TCP. So C.
C. Yes, I can see. Thank you, Sharon. C. Ivy saying C. Nicodemus C. Gail C. So let's see C. Let's see C. Ah, correct. Correct. Finally, Nicodemus, are you able to read this for us?
Which statement describes a connectionless oriented protocol? Option 1, it is known as user datagram protocol. It doesn't require a session between the sender and receiver. It creates a session between the sender and the receiver. It is best used for transmission that rely on speed and not reliability. The correct option is C, which creates a session between the sender and the receiver.
Awesome. It creates a session between the sender and the receiver. That is the correct answer for connection-based protocol. The others are all for connectionless. Awesome. Let's see, submit, and it's correct. So those are your answers. I hope you guys have seen. And now, please make sure that you've done your cases. Wale wa labs, kama mkumaliza fanyeni hizo labs zingine. And then let us meet tomorrow early morning to continue with our classes. Any question before I release you guys? Do you have any questions? Any questions? Cool. Silence means no questions. Guys from my channel, make sure that you've joined your appropriate groups and appoint a leader for your groups. I'll be checking those groups to pick out the leaders. If you don't have a leader, I'll appoint a leader. And then I want us to start working from tomorrow. So have yourself a good evening and let us meet tomorrow. Bye-bye.
Have a good evening too, Pat, and thank you for the session.
Thank you too. Stop sharing and stop. Is that stop